Hey guys, welcome back to my channel. In this video we'll have a brief discussion on the classification of haloalkanes and haloarenes. Before we begin the video, I just want to thank everyone who have supported and liked my channel. And if you have any questions at all on chemistry, you can just throw them in the comment section and I will try my best to answer them. And if you know anyone who has problems in chemistry, just let them know about this channel and I'll try my best to solve their problems through videos and answering them through the comment section. So without further ado, let's begin the video. So if it comes to the classification of your haloalkanes or haloarenes, you can actually classify them based on number of halogen atoms or based upon the hybridization of carbon atom. And this carbon atom is not just any carbon atom. This is your specific carbon atom to which the halogen atom X is attached. Let's start with this one. Let's start with number of halogen atoms present. Okay, based on number of halogen atoms, if you have one halogen atom present in your compound, you say that it is a monohaloalkane or it is a monohaloarene. Mono means one, halogen means your halo means your halogen atom. So if you have one halogen atom present in your compound, you will say that it is your monohaloalkane or monohaloarene. Okay, I'll give you an example of this monohaloalkane. It is your chloroethane. This is your example of monohaloalkane. You can see that this is your chloroethane and this is your one halogen atom attached. So it is only one halogen atom. So we will say that it is your monohaloalkane. Another example is your benzene ring, and you have your chlorine atom attached to it, and this is your chlorobenzene. And again you can see here that there is only one halogen atom attached, so we will say that it is a monohaloalkane. These monohaloalkanes or monohaloarenes can again be classified into three categories, that is primary, secondary and tertiary. If your halogen atom is attached to the primary carbon atom, we will say that it is your primary halogen atom or your primary monohaloalkane. And if it is attached to your secondary halogen atom, secondary carbon atom, we will say that it is your secondary halogen atom and it is your secondary monohaloalkane. And if it is attached to your tertiary carbon atom, then we will say that it is your tertiary halogen atom and it is your tertiary monohaloalkane. I'll give you an example. This is your chloropropane, CH3 CH2 CH2 Cl. You can see that this is your one halogen atom, which means that this is your monohaloalkane, and this is your primary carbon atom. Why is this carbon atom primary? Because it is attached to one carbon atom, hence we say that this is your primary carbon atom, and hence this is your primary halogen atom. Again, another example I'll give you of this secondary halogen atom, which is CH3 CHCl CH3. Here you can see that this carbon atom is attached to two carbon atoms, 1 and 2, and this is your chlorine atom which is attached to this carbon atom, and this is your secondary carbon atom and this is your secondary halogen atom, and hence we will say that this is your secondary monohaloalkane, tertiary monohaloalkane. So if you have three carbon atoms attached to this central carbon atom, we say that central carbon atom is your tertiary carbon atom, and if you have a chlorine atom attached to this tertiary carbon atom, we will say that this is your tertiary halogen atom, chlorine atom, and we will say that this is your tertiary monohaloalkane. Okay, moving forward, if when it comes to your dihaloalkanes or dihaloarenes, you can know by the name itself that it has two halogen atoms present in the compound. So if a compound has two halogen atoms, you know that it's going to be dihaloalkane or it is going to be dihaloarene. Now again, you can actually classify these into three categories, that is your geminal, your vicinal, as well as your polyhaloalkane or your polyhaloarene. If you talk about geminal dihalide, you can what is geminal? First of all, geminal is your structure in which your carbon atom is attached to two halogen atoms. So if you have two halogen atoms attached to a single carbon atom in your complete structure, then we will say that it is your geminal dihalide. In this case, you have two halogen atoms attached to this carbon atom, so we will say that this is your geminal dihalide. What about vicinal dihalide? Vicinal is a Greek letter which means neighbor. So these are your neighboring halogen atoms. All these are your halogen atoms which are present adjacent to each other or attached to the adjacent carbon atom. So this is your first carbon atom and this is your second carbon atom, and these halogen atoms are adjacent to each other, so we will say that these are your vicinal dihalide. What about polyhaloalkanes and polyhaloarenes? The concept here is also fairly simple. If you have more than two halogen atoms, then we will say that it is your polyhaloalkane or your polyhaloarene. I'll give you one more example of this. For example, if you have your carbon atom which is attached to CH3, or scratch that, if you have your carbon atom which is attached to 1, 2 and one hydrogen atom and 3 chlorine atom, you will say that this is your chloroform, and this is an example of your polyhaloalkane. Another example is fluorine atom, fluorine and a hydrogen atom, so we will say that this is your fluoroform or your iodoform, or it could be your bromoform. It could be anything, and it could be also be carbon tetrachloride, or it could be trichlorobenzene. It could be anything, so long as there are multiple halogen atoms or there are more than two halogen atoms, we will say that these are your polyhaloalkanes. Okay, moving on. When it comes to the classification of these compounds based on the hybridization of carbon atom, you can classify them based upon if your carbon atom is sp3 hybridized or if it is your sp2 hybridized carbon atom to which the halogen atom is attached. Now, if it is your sp3 hybridized carbon atom, you can divide these compounds into your allylic halides or your benzylic halides. Okay, what are allylic halides? Allylic halides are compounds containing halogen atom bonded to sp3 hybridized carbon atom next to the carbon-carbon double bond. Okay, what does that mean? These are compounds containing halogen atoms bonded to sp3 hybridized carbon atom next to the carbon-carbon double bond. So if I have a structure which will look something like this, and if I have my halogen atom attached here, then we will say that this is your allylic halide and this is your allyl carbon. Why? Because it is attached to these to this carbon-carbon double bond. So if your allyl carbon is attached to the carbon-carbon double bond, then we will say that and if you attach a halogen atom to this allyl carbon, then we will say that this is your allylic halide. For example, if you have your chlorine atom attached here, then we will say that this is your chloropropene. Or if you have if you consider another structure, if you take this, for example, this structure here, you will have your chlorine atom attached, so we will call this structure as your 1-chlorobutene. 1-chloro, this is at your first position, so we will say that this is your, and there are 4 carbon atoms present, so we will say that this is your 1-chlorobutene. Okay, moving on. Benzylic halides. What are benzylic halides? These are compounds containing halogen atoms bonded to sp3 hybridized carbon atom next to an aromatic ring. The main difference is the fact that these are your open chain structures and these are your closed chain structures, or your aromatic rings. So if you have your benzene ring here, and you have your halogen atom X attached to it, then we will say that this is your benzylic halide, where X could be anything. It could be any halogen atom from fluorine to iodine. Okay, moving on. sp2 hybridized carbon atom. If you talk about sp2 hybridized carbon atom, you can say that again these compounds could be divided into your vinylic halides, as well as your aryl halides. Okay, what are vinylic halides? Again, just focus on this structure. If you have the halogen atom bonded to sp2 hybridized carbon atom of an aliphatic compound, so this is your structure. And if you have your chlorine atom attached to this structure, basically if you have your chlorine atom attached to a double bonded carbon atom, this is your double bonded carbon atom with this carbon atom, and this is your chlorine atom. So if you have this chlorine atom which is attached to this double bonded carbon atom, or if it is attached to this sp2 hybridized carbon atom, now this is your sp2 hybridized carbon atom because it is attached to 3 particular atoms. That is why we call it as your vinylic halide. Moving on, if you have your aryl halides. Now what are aryl halides? Now these are compounds containing halogen atom bonded to the sp2 hybridized carbon atom of an aromatic ring. The same concept here goes for your aromatic ring. If you have your aromatic ring benzene, and if you have your chlorine atom attached here, as well as, let's say this is your, I'll just add another one, let's say I have added CH3 here. Okay, this is your chlorotoluene, or you can also say it as 1-chloro-3-methyl benzene. 1-chloro, this is at your third position, so you can also say it as your 1-chloro-3-methyl benzene. Now this is your aryl halide because these are compounds containing halogen atoms bonded to sp2 hybridized carbon atom. Why is this carbon atom sp2? Because it is attached to 3 particular atoms, 1, 2, as well as your third hydrogen atom. Okay, that was about your classification of these compounds. In the next video we'll talk about the IUPAC nomenclature. Till then, I'll see you in my next class. Have a great day ahead.